I'm Tim Ventura, and we're joined today by Dr. Jack Sarfatti, a theoretical physicist well known for his research into the UAP phenomenon in consciousness. Dr. Sarfatti studied under Hans Bethe and other leading physicists from the Manhattan Project in the late 1950s and early 60s at Cornell, along with studies at the UK Atomic Energy Research Establishment, the Max Planck Institute for Physics, International Center for Theoretical Physics, and work as an assistant professor of physics at San Diego State University. Dr. Sarfatti has described the CIA and DoD asking him to work on both the physics of consciousness and the propulsion of flying saucers back in the 70s, and has developed a model to explain both problems by using mainstream physics of Einstein's theory of gravity and quantum mechanics. So I'm going to read through the latest headlines here. The New York Times writes, Pentagon review finds no evidence of alien cover-up. Washington Post writes, Pentagon report finds no evidence of alien visits or hidden spacecraft. Wall Street Journal wrote, Pentagon finds no evidence of aliens in new UFO report. ABC said, Pentagon study finds no sign of alien life and reported UFO sightings going back decades. NBC wrote, no evidence that U.S. covered up existence of UFOs. CBS wrote, NASA UAP report finds no evidence of extraterrestrial UFOs. And Fox News wrote, Pentagon UFO report finds no alien evidence. Quote unquote, if U.S. won't fess up, other nations will, expert warns. So yeah, I wanted to start out with that because, again, the government has officially acknowledged that UFOs are real and pose a threat to air safety. That was from the Director of National Intelligence. The House and Senate in the National Defense Authorization Act 2024 have enacted legislation on the jurisdiction of UFO wreckage, which is based largely on the testimony of several current and former officials who have sworn under oath that we possess this material. So given the weight of evidence and existing official acceptance, do you think it's right for Aero to report that there's no evidence for extraterrestrials?
Okay. Do you want my opinion?
Yeah, go for it. That was what I wanted to start out with.
Listen, I fully intended not to get into this political stuff, but at this point I have no choice. I'm going to try to be as polite as I possibly can, which is difficult for me. Okay. Listen, I have no confidence in the current United States government. No confidence in any area. I have no and I think I speak for millions and millions of Americans here, at least half the country, or maybe more. We have no confidence in the mass media. It's all propaganda. It's like we're living in an Orwellian. We're living in the combination of George Orwell's 1984 and Aldous Huxley's Brave New World, a little bit of Ray Bradbury's Fahrenheit 451 for people who've read classics in science fiction. We're living in a fake reality here.
Well, Jack, let me transition into the Warp Reactor, because actually that was what you wanted to talk about today. So, and again, so this came out of an APEC presentation, right? That's the conference that I manage. If it's okay, really quick, I want to share the screen, and that way folks can see what we're dealing with here. Yeah, Dr. Michael G. Anderson shared this at the APEC conference, and I would urge everyone in the audience to sign up for the conference. That way they get invites to future ones. And I will drop a link to this in there. So he gave a detailed presentation, and I still have his PowerPoint for it. He works over at, I believe, Lawrence Livermore, right? And this is a theory that incorporates some of your work, and that's one of the things that makes it so exciting. It was the S field, if I remember correctly. Yes. So what I'm going to do is I'm going to take this page down. Again, let me urge everybody to sign up for that. We have links all over the website. We do have a Join APEC link. Okay, so yeah, here is the Warp Reactor concept. He wrote, it promises orders of magnitude increase of intense ion beam energies and respective radiation yields at a fraction of the size and cost of existing Z-pinch class accelerators, and allows the economically viable study of relativistic high energy density physics regimes, right? So we're talking about something that is remarkable. It's new. This is something that his team is working on. From what I understand, and I have not talked to him in several months, this is something that his team is looking for funding for. This project is essentially on hold. They're just waiting to find the right funder for it. And it's a sizable chunk of change, but if they're able to make that work, then we could potentially have a new particle accelerator, new source of energy, right?
Yeah. Now, I should mention, I think he needs $250 million.
Yeah, I didn't
And
want to say that out loud.
yeah,
I thought, you know what, I'll keep that part
and
to
the machine
myself.
is like 60 feet long and 30 feet high, you know. Hey, by the way, just let me make a note, just make a side kind of high strangeness note. There's this character named David Adair. Okay, he's kind of like a Bob Lazar type guy. You know, it's kind of
Yeah,
mixed. It's
he
hard to
goes.
know if he's,
He,
yeah, yeah. But he just, yeah, he's probably. It sounds like fiction, but he says that when he was 17 years old, he was taken to this Area 51 underground base, and there he saw an alien spaceship, which which had a warp reactor in it, warp engine, which was 60 feet long and 30 feet high, the same dimensions as this thing. In
life
1971,
parallels art. Life parallels art. That's all I can
well,
say.
okay, yeah, just let me have fun for a minute. Since this technology is time travel, it's possible that maybe they will. I'm just giving you now a science fiction story. I'm not saying it really happened, but it could be that this picture they're saying that this is the basis of a warp fusion reactor engine. Okay, and it's actually incorporated in a spaceship that's being built at Lockheed Martin or maybe under Area 51. That'll be built, say, 10, 20 years from now. And then since it's a time machine, it goes back to Adair is saying that there's like 20 miles of underground stuff by under Area 50, all that stuff. In any case, it'd be a great science fiction story. So all right, so continue.
Yeah, well, that's what I have for the warp reactor. Now, if you want, why don't I do this? If you can give me 2 seconds,
Yeah.
let me share the original presentation as well.
All right, go ahead.
Okay, so I'm going to put this up on the screen now. So this is Michael's original presentation. Again, this was at the APEC conference. I'll put links in there. The Warp Reactor conference. I'll just kind of go through the different slides there that he used. And this is something that his team over at Lawrence Livermore developed. They have been developing.
Yeah.
As you can see, they have lots and lots of tools and equipment that they have already developed.
Yeah, let me say something about that. Edward Teller created this lab. And of course, I knew Edward Teller as a student back in La Jolla in 1966. I spent about 3 or 4 hours with Edward Teller and Itzhak Rabin at a dinner at Rabbi Pinkus Lipner's house back in 1990. So I knew, and I was at Teller's office I was at Teller's office at the Hoover Institute, and I was with students, and people would ask about UFOs, and he was always very he didn't want to talk about UFOs. He said people are more interested in UFOs than they are in physics. What's going on? That was Edward Teller. So Edward Teller created this, and also Edward Teller's one of his important assistants was George Chapline Jr. from Caltech, and George and I were friends in the 1960s when I was a graduate student at UCSD La Jolla, and George was getting his PhD at Caltech with Fauci, and George's father lived in La Jolla. George's father was a retired Navy captain, and George would always ride down in his he had that Ford Cobra. So we used to ride around in his Ford Cobra back in in La Jolla back in like the late 60s, 1965, 1966. So and then he became like Edward Teller's one of Edward Teller's main physicists at Lawrence Livermore. They helped create the Lawrence Livermore Lab.
Well, so yeah, there you go. Those are the two presentations. So this device, I mean, what kind of power output do you think that this could generate?
Okay, well, okay, you know what? Now I sent you get that thing I sent you where I have stuff about this. This is from Anderson's paper, and you see I didn't show the right equation. All right, okay, so let's just Well, okay, that you see that that Anderson is talking about the Sarfatti plasma metamaterial effects. Okay,
Yeah.
and also Southern. Okay, and then he has um, mathematical models. There we go. Mathematical models for proposed modified with Sarfatti Anderson fields. Okay, this is all from his paper. And then table 9, metric engineering. There it is. The Sarfatti scalar field factor S. That's basically 10 to the 32. Okay, it's a pure number. It's the
Okay.
amplification. What the S field is the amplification of Einstein's coupling of, say, if you want to convert electromagnetic fields into gravity fields, there's a certain coupling factor which is very weak. And in MKS units, the coupling is it's like 10 to the minus 43 reciprocal newtons of force is the coupling of electromagnetic stress energy density to the induced UFO warp anti-gravity field. Let's put it that way. But this factor here would amplify it by 32 powers of 10. But in this machine, this is just the actual Tic Tacs do not have these big machines flying around. So this is just like a test of concept. Okay, but here, this is what's important. For the Anderson proposal, the S is 10 to 32. He's going to make a warp bubble of 1/10 of a millionth of a cubic meter in size. That's what they predict. And the effective G field at the surface of this little warp bubble, the gravity acceleration field, is 16,000 times Earth's gravity. 16,000. Okay. Oh, on there I show the induced gravity curvature is 10 minus 43 newtons to minus 1. That I was talking about. Okay. The sentence in red font with the yellow background, that is Einstein's gravity field equation from general relativity back in 1915, modified by this S factor, this amplification factor. Okay, so that is from Anderson's paper. Okay, now let me say something new. Are you with me? Can you hear me? Okay. So now we have this thing going on with Anderson, but they haven't raised the money, I guess. They haven't built the thing. And it's but guess what? I found out there's a much cheaper way to test the idea. Much cheaper way.
Okay.
This is new. This is new. We wanted to, and so the two main points we want to get to today. One is the cheaper way of measuring, finding out if the S field concept works or not, a cheaper way of doing that, and also update on the white hole force field idea, the anti-missile shield idea. That's important, right?
So should I stop the screen share then, or?
No, keep it on because I'm going to show some stuff. Keep it on. Can you see me at all? Because I don't see myself. Can you see me at all?
Yes, I can.
Okay.
I can. So
Okay.
I'm gonna change. Yeah, I'm gonna change things around a little bit. That way we have a little bit better display. Okay. Yeah, go for it.
Okay. So the new idea. I'll come back to this. Okay, no, okay, since we're here, this is a side. This is kind of fun. Before I get to the physics part. Well, this actually is physics too, but this is from, 1950s when I was a little kid. Donald Duck, Walt Disney. This before Walt Disney went woke. This when Walt Disney was alive, and he, of course, was a conservative. He was an old man. The thought ship. Look what it says. It's the world's first thought ship. Here's Donald Duck and Scrooge McDuck and Louie, Huey, and Dewey. It says, world's first thought ship. Come again. Instead of steering wheels, pedals, and knobs, this anti-gravity craft operates by thoughts alone. Okay. This is like 80 years ago, 70 years ago.
Yeah.
So all you do is punch in the thought mode. Then if you think of going 10 miles east in 2 seconds, the ship does it. will it even go into space? You know, I'm like that. We used to have Mayor LaGuardia when I was like 5, 6 years old, late 1940s. Mayor LaGuardia would read the funnies to all the little kids like me, and we every kid in New York, every kid in the whole country, turn on the radio, listen to Mayor LaGuardia read the Sunday comics, Dick Tracy and all that stuff. And of course, Dick Tracy had his iPhone back then. He had the wrist radio, like the iPhone. Okay, so we'll even go into space. It can go anywhere you can think of, boys. In fact, they'll get you to the Black Moon and back before anyone else even gets close. The Black Moon? Yes, us? Okay, now, this is, well, get this. This is pretty weird now. We're now getting into Twilight Zone territory, time travel, okay? Guess what? You know, Walt Disney was very involved in World War II with the OSS, with the whole secret projects, right? Walt Disney,
No,
they
I
made,
didn't.
oh yes, of course, they made propaganda films.
Oh, okay, yeah.
But the World War II, the Nazis, yeah. In fact, I grew up on them. I can remember, probably, about all these cartoons about with Hitler and beating up Hitler and Donald Duck, or was it Goofy? It was very so. Disney was the highest levels of the. Then it was the OSS. There wasn't any CIA, the intelligence services. They already knew about these damn UFOs. This is what I think now. This is what's really going. All this is real. They're conditioning kids like Jackie Sarfatti, 5 years old, watching this stuff. I grew up on this stuff. I grew up on reading about Future World and all this stuff that's actually real now. Me and Hal Puthoff, all these guys.
We have to be careful because number one, Disney is litigious, but then number two,
well, that,
the internet. Once conspiracy theories like this get started, Disney is behind the UFO conspiracy. Once that gets out there, we're in trouble.
Wait a minute, no, yeah, but don't worry, they're not going to sue you. Yeah, if they sue you, I don't think you have to worry about that. Let's not be paranoid. They're not even going to notice. But wait a second, do you realize that Disney, they made a UFO? I don't know what happened to it. They made a UFO thing about 20, 30 years ago, which had all the stuff that David Grush, everybody's talking about. It was already in a Disney movie, and they pulled it. It may still be on the internet. So Disney, I know that Disney company is very involved in the UFO thing with the CIA. All this stuff here, I can tell you, is real. It's real. I have my own independent military intelligence sources. This is not a joke. This is real. This is how it really works, pretty much. And I'm like David Grush. I cannot reveal my source. I've been shown things confidentially.
You mean thought controlled, not, you don't mean Scrooge
everything
McDuck.
Exactly what's said here. Exactly what's said here. Pretty much exactly what's said here. And here you have this guy talking about the same thing. Recently, this is the other, very recently. It's on the wand.
Okay.
He's talking about this. But this guy doesn't know about the Disney.
So the wand, I'm connected with him. He owes me.
Yeah.
I'm plugging his channel now. He owes me. He owes you, technically.
Yeah, of course. But this is all real. Things are not only stranger than we imagine. Things are stranger than the Pentagon and the CIA, than the congressmen and everybody. It's strange that I think they were able to imagine, because their minds are pretty limited. They need Viagra for the mind. They need to be. So, all right. So there we are. So that's pretty interesting. Oh, here we go. He still looks pretty crazy here.
Yeah, before you scroll up completely, so the wand is one of there are a lot of really good people covering this on Twitter. I've been a lot more active on Twitter lately. LinkedIn is also a good place, but UFO Twitter has a lot of really amazing people, and he is one of them. So I do want to put that out there before we move on.
Okay, you know what? Send me a thing. I don't even know how to use UFO Twitter. They talk about. I look for it.
I will send you a list. I've been getting into Twitter lists.
Okay.
And I'll put a link to that in there. I've created some Twitter lists of some key speakers, right? And
Yeah.
There are a collection of people on Twitter who were doing really great research. And then the other thing that I should, and you're familiar with these guys, is the SCU, right?
Oh yeah,
Scientific
CSU.
Coalition. Yeah,
Yes,
they do
but let me
wonderful
tell you about the
research.
CSU. CSU is good and it's also bad. The good, bad, but what's good is that everything they say about the empirical observations is good, is
Yeah,
correct. Okay. What's bad is that they have a low glass ceiling on the physics. They're not theoretical physicists, so they're not very good theoretical physicists. Let's put that
yeah,
this way.
they're very
The
much
most,
empirical. It's very much
yeah, they're very much
empirical.
empirical. They're good providing data for me, but they don't understand warp
Yeah,
drive. They don't understand it.
yeah,
They
yeah.
don't understand Einstein general. They understand very superficial. They don't really get it. So that's the, and then I include Kevin Knuth in that. Kevin Knuth, and I
Well,
also include
I
well
would I would take that back to Arrow and these other organizations.
yeah.
They
Sorry,
what they should be doing
Patrick.
is, this is just my thought. I believe, I mean, within the United States government, they can make all sorts of claims about this, that, and the other thing.
Yeah,
But the expertise for the physics resides in people like yourself. What they should be
yeah,
doing is collecting and distributing and not trying to make determinations themselves.
yeah. Okay, but they haven't done their homework. They haven't. None of them have contacted me. So that
Yeah.
means they're full of shit, as far as I'm concerned. They're irrelevant. They're irrelevant. And by the way, I am in contact with some very powerful people who are pushing ahead on my stuff. You know,
There,
but
I've heard
I
that
can't
they're
get into.
yeah, I've heard that there are private independent projects that are pushing forward, right? I mean,
Yeah, they're pushing
again,
forward.
I think that the fallout from this Nimitz, not just the Nimitz event, but the long-term, results of Chris Mellon and Lou Elizondo and all of this stuff is it has reinvigorated this. It is kind of put fire into the belly of the public. And that's again, for me, that is why this Arrow report is somewhat laughable, I guess.
Yeah, yeah. I mean that's true. That's true. I have my problems with Chris Mellon because he thinks he knows physics and he doesn't. But I, of course, we have a common core of agreement. It's real, it's important, it's military, all that stuff. Yeah, I agree. All right, so let's go on. So we have that. And now okay, now this is the new thing. And let me just say, I'm working with a group in Texas, a startup called Texas Space LLC. And there are some very well known people involved in it. And I cannot mention the names yet until it'll all become public when they decide to make it public. And there's some really important people involved in it. Texas Space LLC. And in particular, I can say I'm working with an old colleague on the physics. It's pure physics now, pure physics, no politics. One of the people involved is Professor Raymond Chow. Professor Chow and I go back to the mid 1960s when I was a young assistant professor of physics at San Diego State. Back, I guess, 1966, 1967, 1968. And Ray was also a young professor at Berkeley. Ray worked with Charles Towns, it was Towns and Shallow who invented the laser. In fact, I think the Nobel Prize. Okay, and then Ray became a full professor of physics at Berkeley. So he's no slouch. Okay, but also back in 1967, I wrote a paper. I was a young assistant professor, and this is also when I knew George Chapline Jr. The whole Caltech. I was hanging out with Richard Feynman, and also I had spent a summer with John Archibald Wheeler and Werner Heisenberg at Heisenberg's Max Planck Institute in Munich. And then I was also at Her Majesty's Atomic Energy Research Establishment at Harwell in England, and I met Abdus Salam at Imperial College. Yeah, a whole bunch of things there. Some of that is in David Kaiser's book, How the Hippies Saved Physics. All right. So, But back at this time, as a result of my spending time with Heisenberg and Wheeler and people like that in Munich at the Max Planck Institute, and also at Her Majesty's Atomic Energy Research Establishment and at Imperial College with Abdus Salam and with this guy Kibble and Goldstone, Higgs, all those guys, and David Bohm. Any case, so I had this idea, and also I had been learning about superfluid helium from Richard Feynman himself. I first met Richard Feynman in 1963 at Caltech. I was working in the defense industry in Newport Beach, a place called Ford Philco Aeronautics. And as a result of all those influences, I wrote a paper showing an analogy between the non-equilibrium macro quantum long-range coherence of laser beams, and superconductivity in material structures. See, superconductors and superfluids are what are called thermodynamic equilibrium phenomena, and lasers are the non-equilibrium analog of superconductors and superfluids, but they operate at room temperature. They don't need, the laser, operates at room temperature. You don't need to be down at the absolute zero like you do for superconductors. Okay. And in particular, if you have just the laser beam inside the material, under certain conditions, they form what are called self-trapped filaments, self-trapped like little vortex tubes of light, self-trapped light from the nonlinear, this is nonlinear optics, the nonlinear response of the electric charges in the material. So I had noticed from the mathematics, just as I'm a mathematical sort of guy, and I had seen that the basic field equations for self-trapped laser filaments were very similar to what's called the Landau-Ginzburg equations for superconductors and superfluids. Okay, so it's like cross-disciplinary. And in particular, in electrical superconductors, you have what's called type 2 superconductivity, in which you get these quantized magnetic vortices of normal material inside the superconductor. See, what happens in a superconductor is called the Miser effect, which is basically the Higgs, a low energy version of the Higgs stuff, all that Higgs stuff from CERN. But this is what happens is you get these quantized magnetic flux filaments in the type 2 superconductors. And to me, they look very much like the self-trapped laser filaments that, guess what, that Ray Chow was experimenting with up at Berkeley.
Okay.
So Ray Chow and I had a brief collaboration by mail. That time there's no email; we used snail mail. So and Ray had told me that that analogy he really helped his work. He saw he saw what I was talking about. So we had this brief collaboration in the, I guess, around 1967 or so. Then in the 1980s. It was the late 1980s, maybe, I think it was 1990, I forget. I think late 1980s, Ray would have a graduate student seminar at Berkeley in nonlinear optics and the projects he was with his students. He has a lot of students, good students like Ephraim Steinberg, who's up in Toronto. He's a major experimental physicist doing fantastic work in what are called the weak measurements, which is very much part of what we need for the metric engineering of the warp drive. What are called the Yaki Aharonov's weak measurements. There's a whole other thing at some point we get into. But in any case, Ephraim was a grad student there, and I used to just sit in on some of his graduate student research seminars up at Berkeley in the late 80s. So we connected again. And now we're connected here at Texas Space, which has been set up at the moment by a young guy named Juan Faria. He's 10 years in the Marines, back in, 10 years in the Marines. And then when he got out of the Marines in San Diego, he got a degree in Homeland Security at San Diego State, where I used to teach. And then he has his own security firm, he's a cyber security guy. And
Now,
he's
Jack,
also
do you have a website for Texas Space that I could share?
and he'll get in touch with you. Yeah,
Okay.
I think they're. I don't know if they have a website. This is fairly new, and he. But also, he's a protege of Congressman Pete Sessions, Republican party, and they asked him to run for Congress in Texas. Yeah, he's only 38 years old. He's young, and he didn't win. He did a primary, but he got a lot of he's kind of being groomed for political stuff. But I'm glad he's not going to politics right now because he is starting this Texas Space LLC with Ray Chow. Okay, and Ray, who's a former Berkeley professor, has a whole group of people, other physicists that are now all in a part of Texas Space. I'm not officially part of Texas Space. I'm just an advisor. I'm not going to be officially, I'm not an officer of Texas Space. I'm just, in the background helping them any way I can in an informal kind of way. But Ray is going to be more officially involved, and there are other people, several, a bunch of PhD physicists and engineers. One is an MIT PhD. We have a real professional with good, Berkeley, MIT, people like that, PhDs, physicists and engineers involved in it. And so in any case, Ray Chow has this idea of what he calls a gravity spin radio. What Ray is showing is that you can detect gravity waves using magnetic spins, quantum mechanical spins in certain materials that are quantum entangled. Okay, and the comment is sort of like quantum computing with quantum entanglement, all that stuff that that I helped initiate, and he thinks you can get a very strong coupling, so you can make very efficient detectors of gravity waves being converted into electromagnetic waves. So, for example, now we have the LIGO, we have all this stuff where Kip Thorne and these things in space, multi-billion-dollar, sort of like these huge mega projects that are detecting the gravity waves from black holes. It's about far away in space, back in time. And Ray seems to think that we can make very small, like little iPhone level stuff, iPhone detectors to detect these same gravity waves using this.
Yeah, and and he presented that at my APEC
Oh, he
conference
presented.
as well.
Okay, so good.
So I can put that up if you like, or
put that up. Yeah, put that stuff up when you edit. Okay, yeah,
okay.
Just edit it and stick that in. And now the thing is this: what we're trying to determine is whether or not you could go the other way around. Can you also efficiently convert electromagnetic waves into gravity waves? In other words, not just a passive detector, but an active transmitter. There are some issues we have to resolve. If you can do that, that will revolutionize cell phones, for one thing, because you instead of using electromagnetic signals which can be jammed, you could transmit your information on these little sort of like gravity beam lasers sort of thing. Also, they go right through material, so you can use it for underground. Okay, suppose the Israeli army is looking for Hamas tunnels. So you can with these things, you can see them very clearly. And also, if you had these things up in space and space satellites, you could beam down and you could just detect Russian or American nuclear carrying submarines under the ocean. They're totally exposed.
And so you're proposing an updated Cavendish balance experiment.
Oh, wait, I haven't gotten there yet. No, okay, no, this is separate. Do not confuse. Don't the Cavendish. I haven't gotten there yet. This is a separate project. This is the Ray Chow. It's the quantum mechanical project. It's quantum spins with quantum entanglement, and it uses certain special materials. Now, I think, I don't know what Ray revealed publicly, but this is a separate project. This is the initial project of Texas Space, which has profound military defense implications if it works, as it seems that at least there's a chance if it works, okay? It'll revolutionize satellite communications. It'll revolutionize military communications. It'll revolutionize the cellular telephone industry if it works. Yeah, there has to be proof of concept, okay? So that's what, and also they have patent agreement. They're getting patents. Texas Space has a joint venture with the University of California at Merced to patent Ray Chow's idea. So you have, yeah, if you could show some of Ray, you know, just digress when you edit and show what they're talking about. So that's a separate, that's one project. That's Texas Space. Okay.
Okay.
But now I'll segue into this Cavendish. Okay. As a result of me discussing things with Texas space physicists, in particular a guy named Nathan Enan. He's one of Ray's, I guess, students or associates. Ray has a, you know, like a little coterie of people around him, and and then what had happened was, let me get some water. We have to go back 3 years ago when I was briefly working with Keith Wanzer. You remember? You know, did you know Keith?
Yeah. You guys working closely together for quite a while.
Yeah. Okay. So we're trying to figure out this S field stuff. And of course, the subject of the Cavendish experiment came up back 3 years ago. Okay. And what is the Cavendish experiment? In the history of gravity, the Cavendish experiment is very, very important. You know, you have first Isaac Newton. Well, of course, you have Galileo, you know, but Isaac Newton, during the plague, whenever he develops his theory of gravity and mechanics in general, and, you know, the Principia Mathematica, and so he has the basic idea, the inverse square law of gravity. He explains the motion of the planets is the same as the falling apple, you know, that whole story. And but then Cavendish did an experiment to measure Newton's constant. This is Newton's constant, G.
Okay.
It's like 6.7 times 10 to the minus 11 units in what I call the MKS system. You know, with meters and kilograms and stuff like that. Kilograms, meters, seconds. And it's a fundamental constant. It's like charge on the electron, like Planck's constant. It's a fundamental constant considered to be the same everywhere all the time in the universe. At least that's the assumption. Okay. Dirac had a theory that maybe J would change in time, cosmology, but that's right now everybody thinks this is a fixed number. Do I have the number written down here somewhere? No, I don't. Okay. So Cavendish measured this back a couple of hundred years ago. I forget exactly when. And this was the first great experiment testing Newton's theoretical equations, okay? And Cavendish did this, and in fact, this was up at Cambridge. Today, one of the top material science laboratories is called the Cavendish Laboratory at Cambridge University. Where, you know, Brian Josephson, Nobel Prize, you know, I know Brian, we fight with each other. I know Brian also since at least the 70s, I think the 60s actually. Brian Josephson is a retired, you know, professor from the Cavendish lab. So the Cavendish, so yeah, this is like the very beginning of physics. Okay. All right. Now, there is in gravity theory, but just now before we even get to Einstein, in Newton's gravity theory from the 17th century, I guess it is, 17th century, there are three kinds of mass. There's what's called inertial mass, the inertial mass. What is the inertial mass? The inertial mass is Newton's second law. You have a particle, you apply a force F, it has inertial mass M, and it gets an acceleration A. F equals ma, right? That's the inertial mass. How much does the damn thing accelerate in, say, meters per second squared acceleration, like the acceleration of gravity? Okay, that's the inertial mass. But there's also what's called passive gravitational mass. what is passive gravitational mass? Passive gravitational mass is you step on a scale on the surface of the Earth and you weigh yourself in kilograms or in pounds, okay? And that's thought to be, that is your passive gravity mass is coupling into the Earth's gravitational field. mg, that's F equals mg, right? The way where g is acceleration of gravity. So there are two different formulas really. We have your weight is equal to your passive gravitational mass times the acceleration of gravity. But we also have a more general concept of any kind of force, not just weight, any kind of, it could be electrical force, is equal to the inertial mass times the acceleration. Now, what Galileo discovered back, I think, in the 16th century, even before Newton, dropping stuff off the Leaning Tower of Pisa, all that stuff, okay? And they've done it up in the space station to confirm it and everything. If you go on videos, you see the astronauts dropping a feather and dropping a steel ball on space, and they all go at the same rate, all that kind of stuff. Oh, well, yeah, I guess they do it there. No, they did on the moon. I guess they did on the moon. I'm sorry. They did on the moon. Now, in the space station, it'll float. What I said was wrong. In the space station, they would float. Now, I think on the moon, the astronauts on the moon, because of the vacuum, see, they have a good vacuum in the moon. They drop the two things. They hit the surface of the moon at the same time. So I made a mistake. That was my 84-year-old mind got a little confused there. Like Joe Biden. I'm not as bad as Joe Biden. Okay. Right. So, in any case, so where was I? Okay. So we have So the point is that the equivalence principle of Galileo, which was later generalized by Einstein, is that the inertial mass equals the passive gravity mass. Let me say, inertial mass is the same as the passive gravity mass. Okay. So, but remember, the passive gravity mass is how the particle responds to an external gravitational field. It's like a charge, like a gravitational charge. It's like electrical charge. Electric field with passive gravity mass in a gravity field. Okay. But now we have this new thing called the active mass. The active mass is how does mass generate a gravitational field? That's a very different physical situation. How does it generate a gravitational field? And normally, when you get on a scale and when you weigh yourself, see, that's what's called a test particle. In that thing, in experiments and measurements that like weight measurements, you ignore the gravitational field generated by the object that's being weighed because it's usually so small. I mean, say we weigh 200 pounds, but compared to the Earth's mass, I forget hundreds of millions of tons. Okay, maybe more. I forget it offhand. So the point is, there's no direct measure of active mass usually. All right, but people normally they just assume without real testing that the active mass is the same as the passive mass. Okay, that's what's generally assumed. That's what you learn, and that's the consent. That's the group thing, the consensus. Now, what I realized back in 2010. Okay, let's a little bit of history. It's you had the hippie say physics with the CIA involved with all of us in the SRI remote viewing and quantum stuff. Well, how the hippie say physics bestseller book. David Kaiser, MIT professor. He mentions my name over 600 times in that book. Okay. So the CIA and the defense and the Army and the Air Force guys from there. And I had just, I had been at San Diego State. I'd come back from England and Munich, Max Planck Institute. My professors at Cornell had built the atomic bomb, Hans Bethe, all these guys. So I'm an Ivy League guy. So, of course, the Central Intelligence Agency keeps track of all these guys who were students of the guys who built the atomic bomb. Plus, I'm invited to Trieste, Italy, where I'm with Russia. This is the Soviet era. The Soviet Union is, very active. 1970, 74. I'm over in Trieste, Italy, at the International Center for Theoretical Physics, with Soviet physicists and Indian, international. I was even taken into Yugoslavia. I was at the in Dubrovnik at the and Tito was still the head of Yugoslavia then, hadn't broken up.
Mm.
I spent several days as a guest at the Institute of Nuclear Physics in Dubrovnik, Yugoslavia, and Fred Wolf was with me. He was over in Bulgaria. So the point is, we were in touch. The KGB was all over the damn place, as was the CIA. In fact, there's even a movie called The Recruit, I think, and it's with that asshole. He's a great actor, but he doesn't. Robert De Niro, and I forget who else. Another famous actors in it. And in that movie, The Recruit, they send this CIA guy. They send him to Trieste, the same place I was at. Because it's like a listening post where all these during the Cold War, all these intelligence guys, KGB, MI6, MI5. And when I was at Her Majesty's Atomic Energy Research Establishment, I was living with these guys from MI6 on campus there at the Atomic Energy Research Establishment. It's a place called Ridgeway House. It used to be an RAF offices and U.S. offices during the Battle of Britain, the Blitz, and there's Spitfire air bases right down the road and everything. And a lot of these guys, I was there like in 1966, 20 years after the war, and a lot of these guys who had been in the military, they stayed and became part of the Atomic Energy Lab. It's kind of at that point, Harwell was like Lawrence Livermore. It's a British equivalent of Lawrence Livermore. Okay, and I used to go over there from La Jolla and to work over there. But in any case, so where are we at? So back to the Cavendish experiment. In any case, I have now was it 2020? I'm with Keith Wanza. Oh yes. Oh yeah. I don't want to say it. So let me get back on track. You may want to just edit some of this stuff out, but it's 1975 or so, 1975, and I'm being financed partly by the government, by this guy George Koopman, who's an Army spook. We're getting money. This is the Physics Conscious Research Group. This is in How They Say Physics. Confirm this, and we're financed by the Army Tank Command, the Air Force. And guess who else? Lawrence Rockefeller. Lawrence Rockefeller is giving us money too. It's PCRG. We have this facility. We're up on top of Nob Hill, a big place, and Lawrence. Okay, and also this is the case with Brian Josephson from Cambridge, the Nobel Prize. Brian Josephson. Brian Josephson spent his honeymoon. He just got married to his wife Carol. He spent a week or two, maybe 2 weeks, with me in my place in San Francisco. And he was commuting down to SRI with Puthoff and Tog and all this, paranormal stuff. There's even a newspaper article how Brian Joseph is, visiting us. Okay, we're being funded by Lawrence Rockefeller and the military and all this stuff. Okay, some of it. This is I'm pretty sure in David Kaiser's book. So in any case, at one point, this guy George Koopman, who by the way comes from the New York Times Sulzberger family. George Koopman at that time. George Koopman. Okay, Christopher Mellon is George Koopman 2.0. There's George Koopman comes from a very wealthy they're a Jewish family, but the Sulzberger, they're in New York Times. He's part of that family. Rich kid, trust fund kid. Went into the military, became, they just like they recruited him into the intelligence. He comes from that class, right? But like Ivy League back then, especially, I was sent to the Ivy League by the military, by the way. Okay, so he's funding, he's giving us money, and by the way, he's also in charge when Timothy Leary gets let out of jail by Richard Nixon. Tim Leary became part of our group. And his case officer was George Koopman. This gets so crazy. All right. But it's all true. It'll all be confirmed. In any case, so I'm up there with George Koopman in our place that Lawrence Rockefeller and Georgia paying for, right across from the Grace Cathedral, top of Nob Hill, where Brian Josephson spent his honeymoon. He had his own separate little apartment in this big complex that was being paid for us. And I think Saul Paul Sirag was there, and George was trying to show us, he was trying to give us CIA agent training. He was trying to show us what's called situational awareness, where you go into a room, there's a bunch of people in the room, and you have to sort of see, who's wearing what color, this and that. And then he brought out a little thing of tools, and he says, look, with this, you could open any lock. And he's trying to show us how you open the locks. He tried to do it, and he couldn't do it. This is very funny. Yeah. This is like right out of Monty Python. I mean, it's. Oh, by the way, George Koopman, if you look, he created the movie The Blues Brothers. He was the technical consultant for the Blues Brothers. Okay, Koopman. Okay. And then at one point, Koopman says, he gets pretty serious, he says, and we had fun with him. He was like, yeah, we were wild. And Koopman says, listen, guys, the CIA wants to know two things. The most important, he says, one of the reasons, says the CIA was created partly because of Roswell UFOs. Back in 1975. UFOs. And we want to know two things. They want to know two things. How does consciousness work? Number one. How do flying saucers fly? Now we didn't know, back then we didn't know. Yeah, he didn't realize that they're two sides. Yeah, this is Lenny Sussman. This is ER equals EPR. There's all this hologram universe. Of course, I had actually had a little bit of ER equals EPR back in my book Space Time Beyond, published around that time. Okay. Lenny Sussman and I had worked together at Cornell in 1963 and 1964. We knew each other. And in fact, I even stayed at Lenny's house in Berkeley. And said when he left Cornell, it was at Berkeley. And I also had met him and with David Finkelstein at Yeshiva University. We sort of kept in touch. Okay, and although not recently. And so they said, how do flying saucers work, which is warp drive? But we didn't have the concept of warp drive back then. It was just as stupid as Kevin Knuth is still stupid today. Okay, or Avi Loeb. They don't know. I didn't know back then. We're still thinking rockets, right? And special relativity. It took a long time to get to the warp drive concept. And so, and how does consciousness work? And that's the whole conscious artificial intelligence thing, right? Okay, so the two sides, and it turns out that they're two sides of the same coin connected together by the quantum gravity. That ER is Einstein-Rosen. That's quantum gravity in 3 dimensions of space and 1 dimension of time, and the quantum entanglement is the hologram screen. That's screen, and that's 2-dimensional physics and time, and in particular in condensed. This gets right into the metamaterials. The metamaterial problem is basically 2-dimensional physics. It's it's what are called metasurfaces. What the fuselages of these machines, these warp drive time travel machines, I think are layered metasurfaces. That's a whole thing. And that's where quantum entanglement plays a key role. And not only that, they're conscious. See, they're conscious.
So you were talking about so Raymond Chow, and you have a new Cavendish experiment, right?
Yes. Okay. Yeah. Oh, you have the history of Cavendish. So, in any case, what happened was, as a result of the CIA back in the 1970s asking me to work on both conscious, basically what we now know is conscious artificial intelligence, the whole conscious computer thing, and propulsion of UFOs. And as a result of that, I gave a talk at Orlando at the DARPA NASA 100-Year Starship Conference, which I had a role in helping to create that. And General Pete Worden, who was then head of NASA, and he was a retired Brigadier Air Force General, Space Command, who also has a PhD in astrophysics from the University of Arizona. Okay. So, and I got to know him, and he invited me down to Orlando, and it was late October of 2011, I believe. And by that point, I had come up with the idea. I gave a talk on low power warp drive using metamaterials. And I forget how but in any case, gave the talk there. You can see it's there. And in fact, Sharon Weinberger, who's a defense journalist in Washington, D.C., she wrote an article about the whole meeting with me on the BBC. You can see on the BBC website, 100-Year Starship, something like that. So the basic idea I got back in 2010, 2011. And then what happened was then 10 years go by, it's like right before COVID starts. And I somehow hook up through James Woodward, Keith Wanza is on the same faculty as James Woodward at Fullerton State, Cal State, Fullerton. And so this idea, so the idea is this: if it's warp drive, and then we have that guy Thor, that UAP guy Thor, he came up with the same idea but didn't have the theory. But I already had it 10 years ago. But he good that he has it, and other people playing with it too. So I said the only way it can work is that if the coupling in Einstein's field equation is not a fixed constant, it's not weak, it could be made strong under certain conditions. And that once you have that idea, you're home free. Then everything becomes obvious. Once you have warp drive, you don't have to worry. You can easily explain the apparent high accelerations and all that stuff that Kevin Knuth talks about, right? What Kevin Knuth and those guys and Avi Loeb and Kirkpatrick.
If I could interject for a moment, maybe you should make a statement directed towards Eric Weinstein, who has been actively asking about this kind of physics, because I've seen statements on Twitter by him.
I have tried, but I'm sorry to say, Eric Weinstein's an asshole. He said, I pissed him off. So he pretends, he just refuses to talk to me. I'm willing to debate him anytime. I've tried. I said, I know, because he has a stupid theory. I said it was a stupid theory. Seven times. I basically told him he's an intelligent fool. When Einstein got intelligent fool, that they make something simple overcomplicated. He's a smart guy. Don't get me wrong. He's just smart. I'd like to, Richard Feynman. I sort of modeled myself with Richard Feynman. Richard Feynman used to be very, very nasty with his peers who he thought were being stupid or arrogant, pompous. With students, he was very nice. And there's a whole bunch of stories about Richard Feynman, these guys. But Eric, if Eric were intellectually honest, we would debate this topic. He'd be face to face, like we are right now. And maybe one day he'll come around because he won't have a choice. Okay, but and it's the same for a lot of these guys. They're afraid of me, actually. They have good reason to be. Okay, so where were we at? Wait, so I was telling you. Yes. So I want to get to the Cavendish experiment. Let's get back to the Cavendish experiment. All right, here we go. The Cavendish. So if the data of the UFOs, from Commander Fravell and stuff, if that's real, that means that the coupling constant in Einstein's gravity field equation is not a fixed constant. It's a variable that can be controlled. This is not that crazy an idea, because in quantum field theory, what I call renormalization group, quantum electrodynamics, like the coupling constant of electric charge to electromagnetic field depends on energy scale. It changes. And that's because you have bare charge, you have these virtual electron, it's a whole kind of quantum field. So it's not at all a crazy idea. What is a little different is that normally the changes what happens in the case of the electric charge in quantum electrodynamics, as you go to higher and higher energies, as I recall, the electromagnetic coupling constant, the coupling strength gets stronger. Because what's happening, you're seeing the bare charge. See, the bare charge of the electron gets shielded by a plasma virtual electron positron pair, so it's called screening. It gets screened. So as you go to smaller and smaller scales, which means higher and higher energy, the fine structure constant, that 1/137, will actually get bigger, somewhat bigger. Okay. On the other hand, the strong and weak forces, what are called non-abelian, because they're nonlinear in a certain sense. The strong and weak forces, they go to higher and higher energies, they get weaker. And in the end, the electromagnetic force is getting stronger. The weak and strong force get weaker, and they all merge. I forget where exactly, a little bit below quantum gravity. I forget. Let's say I think of quantum gravity as like 10 to 19 billion electron volts scale. Then I think they all merge at maybe 100 times or 1,000 times weaker than that. So the idea of the coupling between the fundamental interactions changing as a variable is not a crazy idea. That's already in standard quantum field theory and things called the renormalization group. But what's different about that is, number one, you can't really control it in the laboratory. You just have to keep sending higher and higher energy. And the changes happen at higher and higher energies, smaller and smaller scales. What I'm talking about, warp drive, is the very opposite. What I'm saying is that the gravitational coupling, which is very weak at high energies, should become, well, at least in intermediate energies, that within certain materials, the metamaterials, when they're in the right situation, in this further condensate thing, that the coupling should get bigger. It's called the IR limit. Okay, so it's kind of the opposite, but it's similar. It's not that great. And the point is, once you admit this general idea that these non-human intelligences, or not from our time period intelligences, are able to do what we see them doing because they're able to control the strength of the gravitational coupling in Einstein's field equation, well, then everything becomes very simple, conceptually speaking. Doesn't mean we know how to manufacture it, but we understand it. See, it's the difference between knowing how to do something in the lab and understanding it conceptually. Yeah, you won't know what to do in a laboratory or in technology unless you have the right idea conceptually. So you first have the right idea, and then you develop it. Okay, so none of these guys still don't have the right idea. Eric Weinstein doesn't have it. None of them have it. Al Puthoff doesn't have it. Eric Davis doesn't have it. They don't have it. Unless now they're copying me and not telling me. But Michael Anderson has it. Michael Anderson understood it, right? He understood it. Anderson understood it. Some people do understand it.
Yeah. So, and what this comes down to is you have another way to test Michael G. Anderson's warp core reactor.
Yeah, we don't need the $250 million. We do not need all that. As a matter of fact, I will say that there are people in the private sector who are now trying to figure out how to do this experiment. The Cavendish experiment is the situation. And you have these gray spheres, capital M. That is the active gravitational mass. In other words, in this experiment, they're looking for the gravitational field generated by the big gray spheres, okay? Active gravitational mass. Too bad I can't draw on this. Can I draw on this? Hang on a minute. I guess I can't. No, I guess I can't. Can I? No. All right. The red spheres, little red spheres, are considered only passive. Red here means, okay, red balls are passive gravity mass. They're like test particles. The big mass, the gray mass, is so much bigger than the red mass that to a good approximation, you can neglect the gravitational field created by the little red balls. We're going to pretend they're not even there. So the red balls have zero active gravity mass, but they have passive gravity mass, which is equal to their inertial mass by the equivalence principle. The gray things, we don't care. They're the source. They only have we only care about their active gravity mass. We only care about the gravitational field So what this experiment is doing, it is measuring the attraction of the little red balls to the gray balls. Okay. And there's a torsion wire here. Okay. And what happens, everything is clamped. See, it starts off in the position with the pink, that pink position. Imagine little red balls. Whoop. Imagine, oh, that's good. Had little red balls. The red balls start off at the pink position. Everything clamped. And there's a torsion wire there, electrical force wire there, torsion wire, okay? And so what you do, you just unclamp the red balls, and because they'll be attracted to the gray balls, right? And what you measure, the thing will oscillate a little bit. It's common. You got to read the Wikipedia. Just read the Wikipedia article. And the basic thing, you measure theta. The phi comes to equilibrium position. You measure theta and little r. Little r is the separation between the red and the gray. Okay, all right. Any questions so far? Do you have any questions? Do you understand what I'm saying?
Yeah, I would say, yeah, go for it.
It's clear? It's clear? Okay.
Yeah, I'm sure you'll get lots of audience questions, but yeah.
Yeah, okay, so now the issue is this. Capital M depends on the S field. Because the active mass, capital M, is what's called the square root of S. The square root of S times the passive gravitational mass. Times the gravity. Yeah. This gray ball has a passive mass, has an inertial mass, else has active mass. But the active mass is basically the square root of S, roughly speaking, the square root of S times the passive mass. So the point is, if you can make a special material in which you can change S at will by enough, and then you just watch as S in time, this is, in real time, as S is changing, theta changes too. In other words, a cause and effect. There's a simple relationship between theta and S. And that's what the experiment is going to measure. Because it's measuring G. G doesn't change. See, G is an invariant. So that's the idea. So this is the, how do I do this? How do I do this? Okay, so these are the equations. See? These are the equations. This is Newton's G. Can you see my little screen? Can you see my little
I can. Your mouse pointer.
Okay.
Yeah.
Okay. So this is G. This is Newton's G. It's a universal constant. That doesn't change. That's fixed. But S is a control variable, and we can change square root of S. So since we're changing the square root of S, and since G doesn't change, then and K doesn't change, that's a fixed. These are the passive masses, they don't change, and L doesn't change, they're fixed. So what the variable is R squared theta. So you have a constraint. R squared theta changes in such a way to compensate the change in S, okay? And when you do this is it. See, you change S goes to S prime, which is the original S plus a little change in S. Theta goes to, all this. G goes to G, but delta G is 0 because that's the assumption. Okay, delta G is 0. And when you do the algebra, I do that, you get this. This is the final result. This is the change in theta divided by the change in S as a function of the initial theta. The R0 is the initial position of, if you go back here, R0 is the distance here between the pink ball and the center. That's R0, the initial condition. Okay, so you just it's just classical mechanics, simple algebra, high school stuff. If I were teaching a high school class, I'd have the kids learn how to do all this because it's not that hard. Okay, and so this is the Sarfatti equation. Prediction of the S field, if the S field is fixed, is there, and if it's a control variable, see this is S, you change S, here's the control, you change S, and theta must change, and this is initial condition. Okay, L is fixed, R0 is fixed, and theta is a dependent variable, S is the independent variable. And you change S, and this is the rate of change of theta with respect to this. So this will all be measured in the lab if they can figure out how to change S in the gray ball. So that's the problem. But this is not a $250 million high energy. This is low energy. You could do this in a garage in principle. Well, you need a very sensitive lab. So my friends have such a lab. They have a quantum gravity lab somewhere.
Wonderful.
Okay.
Well, on that note, why don't we close things down for today? I think that we've given people a lot. This is a big
Okay, wait, let me
experiment.
say, okay, wait just a minute, a little bit more. So if they can find the right material that you can control S, that's the first real step toward creating the fuselage of the Tic Tacs, because it's that kind of material. Okay. Yeah. So I think we covered everything. Huh?
Yeah, that's amazing. That's amazing. There's a lot. There is a lot here.
Yeah.
And
So you're
so
gonna have to
I
cut.
think,
Yeah. Just cut and paste and yeah. Don't put in. Yeah. Cut out what we're talking about right now. Put in Ray Chow and put in
yeah,
Anderson. Yeah. All right. And yeah, do your cuts, whatever you want. You do it in little segments. Maybe don't do the whole thing at once. And then eventually put it all together. You may
okay.
want to do little, you could do little teasers. Those work and get people excited about what's coming. Yeah,
Well,
just do
Jack,
little segments.
yeah, so let me stop your screen share again.
Okay.
And
Okay. That's
okay.
good.
Yeah. Well, Jack, let me thank you one more time for your time
All right.
today, sir.
All right. Okay. Okay. See you later. Ciao.